Welcome to this video. I am HasPhysics and today we are going to be going over potential dividers. What is a potential divider circuit? A potential divider circuit is a circuit which has resistors, and a voltage source connected in series. The input voltage will be divided with the resistors depending on their resistances and other values. So now we are going to be going on to one of the two example exam style questions, where it states calculate the resistance of the LDR at this distance. So we're given the volts, we're given the resistance of the resistor over here, and we're given the voltmeter reading, which is 2.4 volts. And it's important when you get these type of questions to write SCPV. So you know that as this area is parallel, we can see that PV means that the voltages in this parallel section will always be the same. So we can see that the voltage across the resistor will be 2.4 volts as well. And in series, we can see that the current will be the same. So the current of this, the LDR and the resistor are going to be the same. So first of all, we want to find the current of the resistor. So we use V equals IR and we rearrange for I. So we do V over R equals I. So we're given V 2.4 and 75 and we just divide them two together. And that is 0.032 amps. So now we know that the current of the LDR will be the same as well due to SCPV. So 0.032, just going to label it. And due to from SCPV, we know that the voltage between the resistor and the LDR are going to be different. So we do the difference of 6 and 2.4, and that will give us 3.6 volts. So now we know that the voltage going across the LDR is 3.6 volts. So we do 3.6 divided by 0.032, and that should give us our resistance. And that will equal to 112.5 ohms. And make sure you don't forget the units. So now we are going to be going on to our second example exam style question, where it states calculate the resistance of the voltmeter. So we write SCPV over here as well, and we see that the reading is 1.8 volts. And from PV we can see that the voltage is going to be the same over here as well. So we can just do the same thing. So 1.8 divided by 40 equals 0.045 amps. And now we want to find the current going through the 80 ohm resistor. So we do 6 minus 1.8 as their voltages aren't the same, and that will give us 4.2 volts, and we already have the resistance over here. So we do 4.2 divided by 80, and when we do that we get 0.0525 amps. And you may be wondering why these two are different even though they're in series. The reason why they're different is because the voltmeter with also has a low resistance, so we have to take that into account as well. So the overall current going through this parallel system has to add up to equal the current going through the 80 ohm resistor. So yeah, So we do 0.0525 minus 0.045 to give us the current going through V. Because we can see that the current over here is 0.0525, and we can label this as X, the current going through V, and we know the current going through the 40 ohm resistor, which is 0.045. So overall, the equation would be 0.045 plus X, which we don't know, equals 0.0525. And so we just rearranged it to find X, which is what we're doing over here. So 0.0525 minus 0.045 would equal to 7.5 times 10 to the power of minus 3 amps. So now we know what X is. X is 7.5 times 10 to the power of minus 3. And over here, from the question, we know that the voltage going through it is 1.8. All you need to do is just rearrange V equals IR to give us R. So V over I equals R. And we just sub the values in. And that will equal to 240 ohms. And there you have it. So thank you for watching this video. I hope you have learned something from this video, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.